Hello and welcome to Unit 10. The first video of this unit is going to revisit one of our old friends, adding and subtracting polynomials. Old friend? Sounds different though, but it's really the same thing. The idea of adding and subtracting polynomials is the same thing as combining like terms. So let's recall, like terms are same variable and same exponent. So if I asked you to do 2x squared plus 5x squared, you could tell me that it's 7x squared. Add my coefficients, the variable and exponent stay. Same idea. If I said let's do 7x plus x, you could tell me that that's equal to 8x, because that's a coefficient of 7, that's a coefficient of 1, 7 plus 1 is 8. The variable and exponent stay is just x. In contrast, if I gave you 10x cubed plus 3x squared, those aren't like terms. I can't combine those. That would be simplified. The term that's new there is the word polynomial. So what is a polynomial? A polynomial is a mathematical expression, an algebraic expression consisting of one or more terms. And specifically, terms are separated by addition or subtraction only. So up here, 2x squared plus 5x squared, I would say is two terms. 2x squared is 1. The addition sign separates. 5x squared is my second term. Alright, so let's do a couple examples. If I'm asking you to add polynomials, I have a 3-term polynomial. More on how we name those coming soon. But these are 3 different terms. 1, 2, 3, separated by an addition and a subtraction. I am adding these 3 terms. When it's addition, we have to do nothing special. If it's addition, just combine like terms. It's the same as if I had given you 2x squared plus x minus 5 plus x squared plus 6. Everything stays exactly the same. Now I'm finding my like terms. Always start with the biggest exponent term. 2x squared, and include the sign in front, that's positive, plus x squared. 2x squared plus x squared. You can write these off on the side if you want to kind of group them. You have a 2x squared in one term and an x squared in the other. Those are like terms. A plus x. Here's another plus x. That's a 5. That's a 6. Not like terms. I can put those here. A plus x with this and a plus x with this. And then we also have a minus 5 and a plus 6. Those are like terms because they're constants. Minus 5 and plus 6. If it helps you to group them this way, go for it. You don't have to. Sometimes you can just look at these and recognize 2 and 1, because that's a 1x squared, combined to give me 3. X squared. Keep your variable and exponent identical. Positive x and positive x is plus 2x. You can see over here the way I grouped it. That's a plus 1, that gives me a plus 2. Negative 5 and positive 6, if I combine these two, minus 5 and plus 6, I get a plus 1. I now have 3 terms, but they're all individual terms, not like terms. I can't combine them anymore. That's it, adding polynomials. Subtracting polynomials is a little bit tougher. This one is the one that is a little bit trickier. The key here is you must distribute your negative, your subtraction, to the second polynomial. So what does that look like? Well, the first polynomial doesn't change. If I rewrite this, it's still 3x squared minus 5x plus 3. It's the second polynomial that does. I have to distribute this negative. That gives me a minus 2x squared. But then distribute here to here. That's tricky, because I'm taking this negative times a minus x. Minus makes this a positive. Do not use double sign. Don't write minus negative. 2 negatives makes it positive. Then I distribute to my minus 4. Minus times a minus, I'm going to add 4. Now it's a matter of identifying my like terms again. Positive 3x squared minus 2x squared. That's my x squared term. I have a 3 minus 2 is a 1. I can write the 1 here or not. It doesn't matter. Minus 5x plus x. That's a minus 5 and a plus 1. With my x term, negative 5 plus 1 is minus 4x. And finally, I have a plus 3 and a plus 4. Plus 3 plus 4 is plus 7. Notice how I've been marking my text. Sometimes I'm just showing as many different ways as I can. 3x squared minus 2x squared. I have one line under them because they're like terms. 2 lines under my x terms because those are like terms. Circled my constant terms. I highly recommend you mark your text in some way in your notes. Now, there are 4 problems on the back that I want you to try. 2 are addition, 2 are subtraction. Go ahead and try those 4 problems. After you press pause, unpause to check your answers. So for number 1, we should have 5x cubed plus 5x squared minus 5x plus 14. The order does matter. We want this in descending order. That's standard form. Standard form is to have your largest exponent term first, second largest, third largest, constant term should always be last. Notice on number 1, I grouped these. I took my first polynomial, 5x cubed minus x plus 2x squared plus 7, wrote it in standard form. That way I could take my second polynomial and just take each term, write it under a like term. Now I can combine. Nothing to combine, it's 5x cubed. Positive 2, positive 3 is positive 5x squared. Minus x minus 4x is minus 5x, plus 7 is plus 14. I didn't do that with number 2, I didn't show that, but you can do that in any way you choose. Make sure you recognize, though, that has to be a minus 7x and a minus 4x squared because you have to distribute your negatives. If you haven't done so, finish 3 and 4, please. Go ahead and check your answers for 3 and 4. If you didn't get them, see if you can figure out what you did wrong. If you can't figure that out, make a note in the side so you can ask in class. The last thing I want to talk about on this video is a quick review of our exponent properties. These are going to play a huge role as we move forward to the next section in our chapter. Remember, multiplying with the same base. You keep your base the same, but you add your exponents. So this becomes x to the 3 plus 5. Add my exponents. That's x to the 8th power. Why? Because x to the 3rd is x times x times x. X to the 5th is x times x times x times x times x. When I multiply these two, 1, 2, 3, 4, 5, 6, 7, 8, I add my exponents. If I have a coefficient, multiply your coefficients. 2 times 5. Add your exponents. I have an exponent of 3. If there's no exponent listed, there really is an exponent of 1, so that becomes 1 plus 3. This gives me 10x to the 4th. That's going to play a big role as we go forward in class and on our next video. Come prepared to ask lots of questions in class, and come prepared to use the distributive property.